Hello, welcome to another episode of FreeCodeSession. My name is Jason Bach, and in this episode we're going to continue to move on with profiling rocks and potentially getting some profiling structures in place and performance testing and maybe do a fix or two. So the last time left off was basically figured out that this TypeDissector is doing a fair amount of work, which it is what it is. The thing that I'm been debating now since I walked away was, well, how do I actually do this? In the sense of what I want to do is how do I explain this? So, okay, I write a test around some kind of performance test around this to make sure that it's actually going to be better, but it's internal. So I don't necessarily want to go through rocks in an indirect way just to test this to see, is it okay? Okay, so then I have a choice here. If I come back up to rocks, I think here I have these two set as internals visible too. And I already have the sketch pad as internals visible too. So maybe it's okay if I do these for the profiler and performance as well. So now they should be actually able to see why am I doing this? Why do I need these any kind of order? Because I do. Okay, so then I can have a test in performance that says okay, this is actually going to be interesting because I'm going to be changing TypeDissector to actually being cached. So I got to think about this for a second. Doing a test before and after, I can't necessarily, like I have to literally change it, and I can't use that thing I found from benchmark either. Benchmark testing really, and this is something I also debated. Should benchmark testing be just public things, or should I be able to dive into the internals? I'm going to have to do a performance test right now because I want to see if I generate a name or a dissector every time I get the same type compared to doing it where I don't, and I have it cached. So for this one-off test, I don't have a choice. I have to I think I have to just I thought I made a performance one as well. I always do that. And I guess I didn't. Let's do the thing making sure everything is the same. Actually, I can just copy all this, and then we'll change those to the right thing. Okay. All right. Type. Nice. Give me your benchmark. Sure. Public string get safe name. Now I'm also not doing this test where I'm concerned about, you know, the core job, the CLR job, where I'm trying to say, could I run this with both? I should at some point, but I think for now, just make sure my phone's, yeah. I think for now, I'm concentrating on .NET Core, and quite frankly, my opinion is .NET Core is going to become the runtime for .NET code at some point in the future. It's already getting there. .NET Framework at 4.8 is essentially, looks like it's going to be frozen at that point. And all future work, you know, and focuses on .NET Core, which leads me to a question of, I wonder if, you know, if mono's always just going to be mono and always there. But I'm not really concerned about that at the moment. So, okay, so let's go back to the TypeDissector. Oh, and I should also, before I check this in, although a lot of my tests would break if I didn't have this in here. You know, that would be bad. Okay, so let's just see a couple cases here. And I should have tests, right? I mean, I should have... Not the one I just added. And rocks tests. It's like simple type, direct array type. It's like pointer array type, by ref. Get safe name with nested open generic. Wow, I got a lot of cases here. I got a ton. Well, although most of these are like the primitive types are rather redundant. So, and I don't think within the TypeDissector itself I don't think there's anything really in here that has anything to do with open generics. I mean, it kind of does, you know, because we split here, but you're gonna, you know, split there. You always do this. You know, if you type full name. So I don't think there's anything in here that I really care about that's necessarily like I have to worry about it being long. What I'm mostly concerned about, again, is the difference going to be if I cache it or not. So let's just kind of grab a test here that I think would exercise a fair amount of that. Yeah, because the pointer stuff, if I remember right, that's all this. This is just getting a name, and that has nothing to do with that. That's just looking at your name and doing a whole bunch of splitting on it. Let's pick one that's like nested open generics. Yeah, so let's do that and come here and say that's in the test assembly, so I don't care about that. We'll reference that. Now let's do it with a closed one. Okay, so we're going to say get new TypeDissector dot safe name, and that again is just what you assigned it to. So there's no return there. And so what I want to do now is just run this and say, what does the performance look like for doing this? Oops, no, not that program. Okay, come back here. Benchmark runner dot run TypeDissector tests. Okay. We don't need that. Okay. Make this the startup. And so I'll run this, and then I'm going to come back, show the results, and then we'll change it so that this is using a cache, and we'll see what the results are. So let's get this running. And come on, you can do it. Okay, so I'm going to cut here now, and then I'll come back and we'll look at the results. All right, we are back, and I'm just going to copy this over to my notes here. TypeDissector work. Current is that. There's a cached. Okay, so right now it's excuse me, it's about 15 microseconds. Yeah. Okay, and there is about 5.14 allocated memory, which that could also potentially be improved too. I mean, there's a part of me that goes, let's close that out. There's a part of me that says, in doing this, can any of this be optimized a bit? You know, like we do a split there, get the, you know, maybe not do a split if those aren't there, because then there's no reason to do a split. Maybe that would be faster. You know, but then it gets really complicated. Like this full name here, you do a split. Well, if you wouldn't do a split, then we still have to look to see if you do a split there, if it wouldn't be a split. So I'm not even sure if that is going to be any help at all right now. So let's do this then. So we're gonna, what do I want to do here? I want to have a private static concurrent dictionary of a type to a type dissector mapping equal to new that. Okay. Then, oh, this is going to break a ton of stuff though, so I don't want to do that just yet. We're going to keep this internal static type dissector create. We're just call it type. And then I have to say type dissector mapping add or update, because we're going to need is so you give the type, but we don't want to add. Okay, how did I do this in Rocks? Because I already, and for some reason, maybe I've been on vacation too long, my brain is just not working very well, because I have this little thing of how do I cache it here. Oh, here's my cache, and I just use, I thought I was using a concurrent dictionary, but I'm not. It's kind of surprising. I have my own locking route. Do I have? Oh, that's in my notes, which is to say, is it actually worth turning this cache off and just doing it instead of me doing the cache. Well, I can't steal that code. So, try. If I don't get or add. There we go. That's what I wanted. Okay, so type or we get a T, and that produces a new type dissector of the type. There. Okay, cool. So now what I want to do in my type dissector test is do that. All right, so let's run this. And again, I will pause and I will come back and we'll see the results. All right, here are the results, and they're better, not surprising, but this is a good confirmation. I'm going to run these tests one more time because I want to do the comparison between the two and have one be a baseline. But you can see here that we have 55 nanoseconds now, which exactly makes sense. That's funny, the allocated is only 88 bytes now, which I guess kind of makes sense because every time I was calling it, I was also redoing all the string manipulation work every single time. So that was adding some memory pressure. Now we only do that once and we no longer get it. I guess maybe that's the thing. So let's do that. Get safe name with cache baseline is equal to true. And now let's do safe name with constructor. Okay, and we don't have two baselines. Get that out of there. All right, let's run that. And again, one more pause. I'll come back with the results. Okay, the results just flew by. I'm going to actually copy this, and then I'm going to put it over in my notes here. Okay, cool. So it's 279 times faster to do it this way, which is good. So, and the allocated memory is much lower. So this would be an obvious win. You know, it's 1, 2, 3 orders of magnitude faster to do this once you got it. And I'm guessing, you know, as again, the scenario is that you're using this mock library rocks to, you have a suite of tests and you have a bunch of things you want to mock. And so you're going to hit all these within one session every way. So keeping a cache of these around, you're probably going to get, you know, at the first one or two, a bunch of generations, ones that are made, but then you're going to like do the ones for int and string and GUID and all the core types in .NET and types that you already have in your target assembly already made. So hitting those again will be significantly less. Now, is this going to be noticeable? Probably not. You know, and as I've always said before, as soon as you make a cache of something, you have a memory leak. So there is a part that maybe at some point, if somebody's creating like thousands of these in a test with like thousands of unique types, then this might actually be counterproductive. And then I'd actually have to look and say, use a cache that has an expiration, or do some strategy to say, you know, only keep a cache around, you know, something cached if it's being hit more than anything else, and keep like a top 10 list or something like that. But this is good. The other thing though is I really should have a way to do this from my diagnostic test to say, hey, what does it take now to generate a mock for this to do it for this type and this type and this type. And this is also the thing I was kind of struggling with is there a way to measure this, to have a performance test such that the compilation stuff doesn't get in the way. As I showed you before, what am I not? Oh, okay, didn't have the focus. There. This is where I came in here and said, get rid of all this. But you're calling this somewhere. And so what I really want to do is say, do the thing where you get the trees, but don't compile it. Right? Because I don't need like the in-memory compiler already gets a set of streets. What I want to do is when you, like right before you do this, is write a test to have that. Nothing calls this. Really? Come on. Something has to call it, yeah. The maker does. And so what I want is a way to say, now create a test that does this but somehow stops at this point and doesn't actually call compile there. Which would be, I think, a little tough because all this stuff is very internal and it is a little interleaved, I have to admit. There's not an easy way to, and actually have to see now what calls in-memory maker, and an in-memory rock is what does it. So you're actually going through like all your handlers, all your namespace to do this. And that's kind of, how do we do that? So I could say, make it with constructor arguments, or here I can do it as well. So I'm just not thinking well enough today to try to do this. My brain is just not thinking right now. I don't know why, but it's not. That's what I do want, though, is a way to have a test to say, do all this except the compilation. And if I can figure that out, then I may do a video to show that. The thing I'm going to end with, though, is, and this may take some time, is I am pretty confident that this change here is what we want. And so making this private is now going to break a whole bunch of code. Right? And it should. Yeah. So I wonder if if I say new TypeDissector EFS. So wait a minute, let's do this. I think I can do a very simple change, EFS. So anywhere you have new TypeDissector, say replace with TypeDissector.create there. And then you won't scroll that. Well, that sucks. Find options, yeah, and CS files, entire solution. So we definitely want to find all and replace all. Yep, I think that's what I want. So let's say replace all. Yes. There we go. Now let's build. Build succeeded. Let's run all tests. As much as I like just having the test editor in here, the fact that it does this where it says, that's being bound by something, well, yeah, I know that. Just run them, please. And once again, I know I preach this a lot, but this is an excellent way to make sure that a change that I just done doesn't break any expected behavior. Because there's a previous video where I did, and nothing ran? Or is it all like... What the heck? No. Stack Overflow. Holy crap, that's... The active... Okay, that was the previous one. It's doing it again. Oh. I got lucky. How... Wait a minute. That's actually wrong. Okay, wait a minute. New type. Because how did I ever get through this? Okay, one more time with feeling. I'm going to run the performance tests again. Because now I just realized I had a huge mistake in how I did it. And I will pause and come back. Alright, I realized some things as I was looking at the results here, and it's essentially the same 3 orders of magnitude, same allocation of memory, and standard deviation is, or the ratio, the ratio, yeah, pretty much exactly the same. And then I realized, well, when I was looking at my TypeDissector tests, these were actually calling both TypeDissector create, but that got changed afterwards when I did the global find and replace. And then I went, aha, and that's why actually this failed, because when I did a global find and replace, it also changed it here, and that's why my test failed. So it took a second to realize why it worked before and didn't work then, and that's why. So now I should actually get some tests to run. And I see some green. And hopefully start seeing some more green and more green. And more green? Green. Okay, so that is good. Problem now, though, is if I say this, now it breaks these tests. I can't do this anymore, even with it being internals visible too. So this whole thing now suddenly becomes invalidated. Which is okay. It's exploratory in a sense, and it's a confirmation that doing that with the cache is actually faster. And it doesn't break any of my tests, which is also good. So I have to admit, I'm a little, let's see here. A lot of things changed. Updated type this to use a cache. It's 1:14 in the afternoon, and I realize that I'm actually kind of hungry, and that might be why I'm not thinking very clearly right now. So made a little bit of a gain with this. What I still need to do is figure out how can I actually write a performance test that I can run over time, that will be resilient and resistance against binary changes, because if I start testing against internal things, it's going to be harder. And that will somehow show that this is actually doing something, of worth, that you can actually see a number. And I don't even know if that's going to be possible in this case, because again, what there's this whole conundrum of if I generate a generate a mock, it goes through all the compiler API infrastructure, and that overwhelms so much of everything else. You really don't see that it has made a change of any significance. It just takes up so much of the time. But if I generate one individually, I don't see anything either because of that. I really need to generate one individually every time and just not do that final compilation step. And that would show me that if I'm generating a mock, that right before that step of doing that, then it'd actually become a lot more helpful. If I can figure out a way to do that, then I can start writing tests, performance tests, that will let me do something like what you're seeing here and be able to see things and go, oh yeah, that actually is better. So, and as a side note, well, the playground's going to stay. Sketchpad is what I'm calling it, which, this has been, at some point I may want to dump this, because at some point, this has been kind of a dumping ground of ideas and things that I've looked at, and you can see I have memory diagnosers in here, and looking for, is there potentially ways to make things a little quicker or not? I don't know. This was the one I did with the name generation. That's right. But now I have that in there. So I think what I also want to do is come in the Sketchpad and say that this is purely for playing with stuff. It's really not meant anymore for benchmarks. And I should move potentially all the benchmark stuff that I'm doing there into my performance test. I'll have to think about that. I think there's some cleanup there as well. So I'm not necessarily ready yet just to commit this and then publish this as a NuGet package that this is good enough, but I think it is a little bit of a win again. I think we found something that will actually help, and then I'll keep diving in. So I'm going to stop talking for now because I'm tired and I'm hungry. So that's it for now. Thanks for watching. Leave your comments and questions below. See you in the next episode.